So on page 4, it says, bless you, the table at the left gives a total, oh, this is actually the grossest example ever. Accumulated gallons of saliva in your mouth every year since 2010. I just added that part. What is the average rate of change? Average rate of change, you guys, bless you. In the amount of saliva between the years 2012 and 2019, indicate units of measure. You guys, whenever I'm asking for average rate of change, good old slope. Between 2012 and 2019, which points would I want to look at? Look at these x-coordinates. Years since 2010. I'm going to look at 2, because that'd be 2012, and 9 is 2019 after 2010. I love it. How would I find the slope between those 2 points? Change in y over change in x. Could we end it right there with the units? Ritzy, you just said 50 minus 17, which are gallons of saliva. So we're going to say gallons of saliva. Ew. Salvia is what I was writing. Saliva. Per, what was their change in x's? Per? Yeah. Yeah, I think we really should put that years since 2010. Gross. And in case you're curious, that is 4.714 gallons per year. Ew. But if it's free response, could we end it right here? For sure, peeps. So again, average rate of change is just talking about change in y over change in x. It's not talking about the rate on a certain day or the rate on a certain year. Okay, let's go right here. Potholes. The graph on the left shows the number of potholes counted along the X meter stretch of road starting from Mr. Belk's house. Yep. What is the average rate of change of potholes along the stretch of road between 20 meters and 80 meters? Indicate units of measure. What would these points be? 20 comma what would you say? 20 comma 5, I agree. And 80 comma 30. So what's that average rate of change going to be? Average just slope. What minus what over what minus what? You know it. Yes, sir. And what would our units be? Oh, yeah, change in y. Thank you. I was thinking meters per pothole. That'd be change in x over change in y. The change in the y-axis over the change in the x-axis. Phew! So that'd be potholes per meter. Thank you. And in case you're curious, that was 0.417. But again, that means it's, never mind. All right. So this is perfect. Love, love, love. Okay. We're getting there. Okay. I'm giving this things in just different ways to show you this info to still get these average rates of change. This is the equation. Gives the numbers of artichokes picked by farmers after midnight. Okay, so what if I give you an equation and I say the number of artichokes picked by farmers each hour after midnight? What's the average rate of change between 6 a.m. and 11 a.m.? What am I going to do? I don't have points to look at. Could I get points? Yeah, plug in 6 and 11. Exactly. I'm going to say A of 6 is what? A of 11 is what? Let's grab our calculators. A of 6. When I plug a 6 there, 6 squared plus 8 times 6. Anyone get A of 6 yet? I got 84. Oh, okay. 84. And then 11 squared plus 8 times 11. 209. Love it. Okay. So if it helps you, maybe some people need to see that as x comma y. X comma y. A of 6 means like f of x. This is my x. That's my y. So what would be my average rate of change of those artichoke hearts? Perfect, bud. 11. I love it. This one does simplify nicely, so I'll just give it to you. It'd be 25. My bad. What would be the units then? So look at what they said. Exactly. We're picking 25 artichokes per hour. Guys, this farm better pick up the pace or else they're not going to be making much money. 25 artichokes an hour, that's not much, you know. Okay, so now it says calculate the instantaneous rate of change. How many artichokes are being picked at exactly 9 a.m. in the morning? Not over an interval. At 9 a.m., I want to know the rate that artichokes are getting picked. And this is saying, all right, use this limit. You guys, 9 a.m. is how long after we started picking artichokes? 9 hours. So I'm going to say my X value, or in this case, my A value is 9. Because I said I want my X approaching some A value. My A is going to be 9 here. So you guys, we're just going to say that we would have the limit as X approaches 9 of f of X minus f of 9 all over, bless you, X minus 9. Notice what I did is I just plugged in a 9 for every single A in this formula. Okay, y'all. It's going to blow your mind a little bit because we didn't do this one yesterday. But this takes a little bit of space. So just give yourself some space. We're going to say equals the limit as X approaches 9. And technically, I should have done a T because we've got T's here, but that's okay. What is my function? They just want to know what's my function with respect to the variable. My function in this case is just, I'm going to actually go with X's instead of T's. We're going to change it. My function is just going to be X squared plus 8X. That's just the function. That's all they want us to write here. So I'm going to say X squared plus 8X. And then they want us to subtract the function when X is 9, or the function when T is 9. What is 9 squared? 81 plus 9 times 8? 81 plus 72? I agree, 153. I love it. So we're going to say minus 153 all over X minus 9. This is a little laborious, you guys. If I were to plug in a 9 here, I'm going to let you know we're going to get 0 over 0. So we've got a factor. We're going to toot. Oh my gosh, Kendall long break. So what multiplies to be negative 153 adds to be 8. I'm just going to help y'all, okay? I'm going to help you because I love you. We're going to say 17 and 9, negative 9. 17 and negative 9. Is that helpful that we had a negative 9 there? Cha-buddy. These are going to cancel. So I'm left with the limit as X approaches 9 of X plus 17. Since I canceled out that whole, we'll no longer get a 0 over 0. 9 plus 17 would get me 26 artichokes per hour is how quickly they're picking at 9 a.m., which just happens to be a little higher than their average, which is 25. So on page 5, I sprinkled in like easier and back to hard because this topic does that. What's the average rate of change from negative 3 to 3? Average rate of change from negative 3 to 3. Straight up, change in Y over change in X's, weren't they? Change in Y over change in X. And then this guy, I was with Lob. I was like, oh, what is f of 3 minus f of 1 all over 3 minus 1? I was plugging it in. Did they ask for that?
No.
Nope. Which one is it?
C.
Just C. Just the setup. Okay, look at this one. We got our calculators, people. Ooh, we got our calculators. Look what they're asking. Average rate of change. Average rate of change from 5 to 60. This is from 2007. Were you guys alive then?
I was born then.
Okay. It's literally incomprehensible to me. That's incomprehensible to me. Here we go.
Just imagine next year.
Wind chill temps, degrees Fahrenheit. Whoo! I got cold just thinking about it. And it's in velocity, wind velocity, miles per hour. If the air temp is 32 degrees, the wind chill is given by this. Wind chill. And it's just valid between 5 and 60. Find the average rate of change. When they want that, they just want a good old slop, people. Good old slope. From 5 to 60. Use that graphing calculator. Don't forget, you don't need to simplify. This is from a free response question from 2007. Some number minus some number over some number minus some number. You do not need to get a final answer. Would it be W of 60 minus W of 5 all over 60 minus 5? I cannot end here because I've got variables. So you need to go find W of 60, plug and write that down. Go find W of 5, write that down. I can't end where I am right now because I've got variables. So my girl Rai Rai wrote 13.050, yes she did, minus 27.009. Is that what y'all are writing? Over 55? Or 60 minus 5? Did anyone get an actual answer? What'd you get, Blake?
55.6 minus 22.1 times 60 to the...
Okay, so you guys, we've got 3 topics to talk about in AP Calc. Limits, derivatives, that's what we're starting out, and then integrals, okay? So defining a derivative, what's a derivative? This is going to be that instantaneous rate of change. We're no longer talking about the change in y or the change in x. It's that instantaneous rate of change, or the slope at one point. And this is kind of fun. This is notation for that derivative. Anyone know how to say this? You've seen this notation before in geometry. Yes. This is how you would say f prime. This one, looks a little funny, and you literally just say it exactly how you see it. dy dx. How you'd say this is dy dx. We're going to say that a lot. Any ideas of this one? Y prime. Who said that? Ritzy? Who said that? Okay, what do you have in Ritz? This one is just saying, this is just d dx of a function. This is just saying the derivative, or d dx is how I'd say that, of f of x. These are all different notations for the derivative, which again is that instantaneous rate of change. When you get pulled over by a police officer, they say you were going 87 miles per hour right then at that one moment in time. And again, these are then this long hand of how to find that instantaneous rate of change. Oh, are these two the exact same? Really, we're really focusing on these guys, but yeah. Whew. This is just I just want to practice this again because this is a lot. So I said, all right, find the derivative, find that instantaneous rate of change of x squared minus 4x using this equation. You guys, we're going to go find that slope, that instantaneous rate of change of this function using this equation. And you guys, I didn't say at a specific x value. This is going to help us find the slope at any x value. So here's the deal. We're going to go plug in f of x plus h minus f of x all over h to this equation. You guys, we need to go plug in x plus h into this function. Let's go do it. We got the limit as h approaches 0. We got x plus h here. So I'm going to have to say x plus h squared minus 4 times x plus h. This is just me plugging in an x plus h to that function. Then we got to do minus the function, f of x. You guys, would I just write minus this or minus parentheses this? We got to do minus f of x. We got to do minus the whole thing, x squared minus 4x, all over h. Let me show you what I just did. We took x plus h, we plugged it into my function. Then they said minus f of x. So f of x is just the function, so I subtracted this. This is f of x. Okay, for chocolate, help me out. What is x plus h squared?
X squared plus 2. Ooh, hx plus h squared.
Perfect, bud. I love it. Minus, let's distribute. 4x minus 4h. We doing okay with that? Then what? Minus an x squared plus 4x. Thanks. Harvey, does anything cancel on top? Yeah, x squared minus x squared. Negative 4x plus 4x. Harvey, everything else has what in common? An h. So can I take an h out of everything? That's huge, Harv. Harvey, what are you having? Okay, what's left when Harvey got rid of all that stuff was a 2x and an h minus a 4. Is that right? Okay. Guess what you just did, Harvey? When h is 0 then, you just found the slope of this curve at any point ever. And you're saying the slope, the derivative, is 2x minus 4. The derivative of this was 2x minus 4, and that means we can find the slope of this curve anywhere. And look what I did. This is that curve, x squared minus 4x. I just graphed it for you already. This is the slope of that curve at any x value, meaning the derivative. So it says use the derivative to find the instantaneous rate of change at these different values. When x is 0, you guys, when x is 0, what do you think the slope of that tangent line is going to be, positive or negative? Does it look negative? So what we'd say is we're going to say f prime of 0. And look at what I just did there. This is not f of 0. This little apostrophe means the derivative. And maybe right here, let's go put next to 2x minus 4. This is f prime of x. This is the derivative. That is the derivative or the instantaneous slope at any x value. So f prime of 0, Ritz, you're so right. F prime is 0. If I plug in a 0 right there, that'd be 2 times 0 minus 4. And what'd you get, Ritz? And at 0, does that slope look like it could be negative 4? Sure. You just found the slope of that tangent line. Okay, what if I wanted to know the slope when x is 1? We'd say, ooh, what's f prime of 1? And this is how we'd write it. F prime of 1 equals 2 times 1 minus 4. What we got? Negative 2. At 1, does this slope look like it'd be a little less than my slope at 0?
Yeah.
Yeah. It's a little less steep. This one was a slope of negative 4. This is a slope of negative 2. Who can help me find my slope when x is 2, f prime of 2? Say that again, Beck. Because you're saying 2 times 2 minus 4 is getting me 0. Hey, does it look like at 0 we got a slope? I'm sorry, at 2 we got a slope of 0. What are you having, Beck? The what? Yep. Hey. Thanks, guys. Group effort. Once we get over to positive 3, f prime at 3, I'm going to do this in purple, is going to be 2 times 3 minus 4. What's that slope going to be? 2. Tatum, boom. At 3, does this look like it's got a positive slope? Tatum, as I go to 4, do you think that slope's going to be even bigger? Yeah, when I plug in a 4 and I say f prime of 4, that'd be 2 times 4 minus 4 would get me a slope of 4. Good job. Tatum, what you have? Find the derivative of this function using this formal definition. And I didn't say at a certain x value. Gross. I said find the derivative. Ew. So you guys, here's the deal. I want to know what f prime of a is. And this is that formal derivative definition of it. So we're going to say the limit as x approaches a, because I didn't give you a certain x value yet. And they're just saying, how I use this notation is I first say the function f of x. So I'm just going to say we got root 3x minus f of a. How am I going to rewrite this if x is a? Minus root 3a. Thanks, bud. Minus root 3a. Seems weird. All over x minus a, because we don't know what point we're looking at for this derivative at yet. You guys, if I were to plug in an a here, I'd get 0 over 0. What can we do to manipulate this that has square roots in it? Multiply by the... Yeah. Check this out. Boom, 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 boom. The conjugate is going to be whatever's with the square roots, different sign in between. Root 3x plus root 3a. Root 3x plus root 3a. Seems Ms. We can do this together. We're all smart people. Limit as x approaches a. Gross. Let's distribute this top together. Root 3x times root 3x. 3x. Positive root 3x times root 3a, and then a minus root 3a times root 3x. What do we do with those middle terms? Don't even write them down. What are we going to end with? Negative root 3a times positive root 3a. Negative 3a. A root times itself always cancels out. On the bottom, you guys, if I were you, I would not distribute that out. Don't distribute it. It looks miserable. Just leave it as x minus a times root 3x plus root 3a. If I plugged in an a, I got 3a minus 3a. I'd still get 0 over 0, people, because we haven't canceled anything out. Could I factor anything out of the top?
Yeah.
Take a 3 out. So you guys take a 3 out. And we're left with x minus a on top. And that is helpful because I see an x minus a on the bottom. They're going to cancel. Then when I plug in my a, whenever I see an x, it says as x approaches a. So replace every x with an a. What would I have on top? 3 over root 3a plus root 3a. 1 root 3a plus 1 root 3a is 2 root 3a's. Whoa, that is my derivative at any a value. A is just an x, you guys.
Oh, because it's approaching.
Yep, good call. We had to replace it with an a. Just whenever my x. So to your point, Ritz, these a's just both represent x's. This is my derivative. This is my slope at any point. And look what they said. Use this derivative, that's what we got, to find the rates of change at these different values. Let's try it. So if we got f prime of 0, my slope at one moment in time, it'd be 3 over 2 root 0? Ew, what's that going to be? Undefined. What would a slope look like if it's undefined? It's vertical. What the heck? Let me just show you something real fast. I want to just do a new blank graph. And if we looked at this function, root 3, where's my root? Root 3x. Here's this graph. You guys, at 0, what is this tangent line going to be, do you think? You guys agree that this slope would be vertical of this tangent line? Then what's my slope? Positive or negative? Positive, and then more or less positive? Less positive. We're saying undefined because that slope is vertical. Then let's go look when x is 3. I use these points for a reason. When x is 3, I want to know what's f prime of 3. That'd be 3 over 2 root 9. That's me just plugging in a 3 in for this a. What would that get me? Root 9 is 3. 3 times 2 is 6. 3/6 is 1/2. All right, so you're saying my slope when x is 3 is 1/2. Okay, it's positive. I'm fine with that. I want to know my slope when x is 12 now. My slope when x is 12, f prime of 12, is just plugging in a 12 right here. 12 times 3 is 36. What's the square root of 36? 6 times 2? 3/12 is 1/4. That's getting less big. And my last one, f prime of 27. I'm plugging in a 27 here. 27 times 3, 81, square root of 81. 9 times 2, 18, 3/18, 1/6. My slope just kept getting smaller. That's a lot. That's a lot. But this is kind of cool that this allows us to find the slope, the rate of change at one point in time and not using multiple. We're almost there, people. We're getting there. You're killing it. This has been a lot. Do you guys remember a little point slope form that we did last year? I call that a little kid version. Is that the same as the big kid version?
No.
Is f of x the same thing as y?
Yeah.
Yeah. And is a just another value for x? Ooh, what's this? F prime is just the slope. Shoot, this is the big kid version now, okay? We got big pig. Okay, so now, all right, this is it. Okay, find the equation of the tangent line. Whoa. If that's my function, you guys, we got to go find f prime. We got to go find f prime. I say we use the as h approaches 0 definition because we haven't done that one in this form. Let's remind ourselves. Limit as h approaches 0 of f of x plus h minus f of x all over h. I understand this is hard, people. We got to go find that in order to write the equation of a line, we need a point, which I can get easily, but we also need a slope. This is going to get us the slope, y'all. Let's go get the slope. We need to plug in x plus h. Oh, wait, what's my x here? I actually gave you the x value here. So we're going to replace each x with a 6. I'm going to just do that so we don't have to rewrite that whole thing. This x is going to be replaced with a 6. We got to go plug in 6 plus h into this function, y'all. 6 plus h into this function. So that would be 6 plus h squared minus 3 times 6 plus h. That's my f of 6 plus h. Then we got to subtract f of 6. F of 6 just says, go plug in 6 into my function. 6 squared is 36 minus 3 times 6. 36 minus 18 is still 18. All over h. Whoa. Okay, people. If I were to plug in a 0 for h right now, I'd get 0 over 0. We got to work some stuff out before we can cancel some things. 6 plus h times 6 plus h. You got this, Cooper. You love this. 6 plus h times 6 plus h.
Okay. That's 36 plus 12h plus h squared.
Perfect. 12h plus h squared. And then I'm going to distribute. Minus 18, bless you, minus 3h. Oh, and then I was a little nervous about this extra minus 18, but I like it. Why do I like? Yeah, negative 18, bless you, minus 18. That adds up to positive 36. Does everything left have an h? Yes. Boom, 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 boom. So the limit as h approaches 0, or the slope, or the derivative when x is 6 is going to be 9. 12. Wait. Okay, so we're going to get 9. That is my slope when x is 6. How I write that is that's my f prime of 6. That's the slope of this curve at the moment x is 6. Guys, that little apostrophe is a game changer. You've never seen that till today, and it is a game changer. That means slope, that little apostrophe. You guys, in order to write something in point slope form, we need a point and a slope. How would I find f of 6? I need a point. If this is f of x, how am I going to get my point? Plug it in. 6 squared. 36 minus 18 is 18. That's my point. Oh, yeah, and did we already have that? We used that right there. Silly me. So we have a point of 618. We have a slope of 9. Can we put that in point slope form? Yes, we can. Y minus 18 equals my slope, 9, x minus, done. Whoa. Oh, this is funky. I gave you a point on the function. The graph of f prime is shown below. So check this out, you guys. That little apostrophe, I feel like it doesn't even show up very well on your printout. So if I were you, I'd write like that is f prime. That is f prime, letting yourself know these are the derivatives. Which of the following statements is true about the tangent line? So you guys, if this is a graph of f prime, these points all represent slopes. These all represent slopes. So when x is 1, do you agree we have the point 1, negative 2? When x is 1, they're trying to confuse you. Does my function have the point 1, negative 1? No. My function has the point 1, negative 2. But my function has the slope of what when x is 1?
Negative 1.
Yes, we have to use this as like that coordinate. We would say f prime of 1 is negative 1 because they gave us a graph of f prime values. So the slope of my function has the value of negative 1 at that point. So which answer are we liking? Slope, yeah. Because it's got that slope. Now, are they banking on people doing this? Oh, the slope of this graph is 0 at that point. Is that why they have these? Does anyone know what that would actually be if I took the slope of an f prime graph? It'd be f double prime, which we haven't learned about that yet. We'll do that later. But we aren't looking for the slope of the f prime graph to get f double prime. I'm looking for f prime's value when x is 1, and that happened to be -1. This is the first day of this. I'm not expecting us to master that. Just seeing it for the first time. One more time. Shown above or below is the graph of a differentiable function f. This is just f this time, not f prime. What is the value of f prime when x is 2? Notice when x is 2, that's my point of tangency. F prime just means the slope of tangent line. Given this graph, could I just count?
Yeah.
What's the slope of that tangent line? What are we rising and running? Exactly. Up 1 over 2. Final answer.
1/2.
You got it.